Welcome back to part 2 of the 15 troy ounce pure gold bar refining series. Here we're picking up right exactly where we left off in part 1. This is our gold that we had heating in some plain distilled water. I'm going to pour this distilled water off of here now. What we'll do is add some distilled water to the gold. Gonna set it up here on the heat, back in the back. Add some more nitric acid. And we're gonna do one final nitric acid boil now. Might be overkill, but it doesn't hurt a thing to do this. And while we got it in this state, it's beneficial to try to extract all the silver and all the base metals that we possibly can before we go to the refining stage. Just let this boil now in some hot dilute nitrate. Got just a touch of fume production here right at the beginning, right there, and then it immediately clears up. And you'll notice that the solution is clear and colorless like water. This means that the nitric boils are complete. I think we've got these nitric acid boils completed now. And so what we'll do is I'm gonna save the acid that the gold is boiling in right now. So I'm gonna transfer this out of this big jar into the smaller one so we can use this larger jar. It's getting kind of crowded in here. It always does this when I'm working with a large lot. What I'll do is add some distilled water, and we're going to set it up on the heat over here and soak it in some distilled water on low heat. I've had this gold soaking in some hot water now for about, well, quite a while, maybe about an hour or so. Do is pour this off now. Okay, the recovery is complete. Now we're ready to go to the refining. This is about 15 troy ounces of pure gold. And by the way, the gold in here is very close to 3/9, just like it is. If I wanted to, I could melt that right there and send it into the big refiner and get paid. But the only way to get it to 3/9 is to refine it with some aqua regia. So what I'm going to do here is add about, we're going to fill this up to about the 700 milliliter level with hydrochloric acid. 700 milliliter level. Here you can see we're already starting to get some action because there's some residual nitric acid left in that beaker. I'm sure of it. And so 15 troy ounces is going to take probably 2.5 liters of hydrochloric acid to get all that to go into solution. But for right now, we're just going to go with this much. I'm trying an experiment here. I don't know if this is going to work or not, but I'm going to try to just use small amounts of hydrochloric acid, add some nitric acid, and slowly dissolve the gold in this small beaker. I've got some sulfuric acid here. We're going to add about half a milliliter to this, and this will combine with any lead that we may have in solution in there, form lead sulfate, and then we can filter it out to remove all the lead from our gold. I can dissolve an ounce of gold with about 150 milliliters of hydrochloric acid and roughly 15 to 18 milliliters of nitric acid. So I'm going to measure out 60 milliliters of nitric acid here. Pour in some of the nitric acid to form aqua regia in the beaker with the hydrochloric that's already in there. We're going to start dissolving some of this gold. Pour this right on in, off the heat. All right, that's about half of the nitric acid. That came off without a hitch. So now what I'll do is measure out about 200 milliliters hydrochloric acid. We're going to dump this right on in to supplement our reaction. Here we go. Measure out about 30 milliliters more nitric acid here. Here we go. We're going to add this in. That's closer to 40. That's okay. I'm going to add this in. Nothing's on the heat. I'm not adding any heat yet. Just trying to get the reaction kicked off. All right, there's 40 milliliters of nitric acid. Here I'm allowing the reaction to take its time. I haven't added any heat. Nice and slow. I've got about 800 milliliters of hydrochloric acid in here, and about 100 milliliters of nitric acid in there to form aqua regia. What we're going to do now is go ahead and put it up on some heat, start heating this up. It would be difficult to try to dissolve all that gold all at once in this small beaker. So what I'm doing is I put in a little bit of aqua regia, and I'm going to try to dissolve part of the gold and leave part of it undissolved in the bottom of the beaker. I've got this at a rolling boil. I don't see any more fume production in here. I'm going to add a squirt of hydrochloric acid. I'm not putting any more nitric in there, not while it's this hot. It's guaranteed to boil over if I did that. I'm going to add this hydrochloric acid drop by drop and see what happens here. See if we create more fumes. And I don't see anything like that. All right, I got all the hydrochloric acid in that dropper in there. I don't see any reaction at all. So what we're going to do is we're going to turn the heat down and let this cool down now. Please remember, I'm making this up as I go, and my thinking is that now that the fume production is gone, we had it on a rolling boil, we should be able to conclude that all of the excess nitric acid that may have been in here was consumed by the reaction. So now what we're going to do is we're going to pour off this gold solution carefully into this beaker. Just collect it over here in this beaker. Back out of the way just for a second. Let's get our beaker that's still got the it's got our undissolved gold in it. That's what that looks like. And we're going to add some hydrochloric acid to this now. I'm going to take it up to about the 700 milliliter level, just like we did earlier. I don't have any heat on, so that hot plate is not hot right now. Let's measure out some more nitric acid. I'm going to go with another 60 milliliter dose of nitric acid. That will make it 70. And what we'll do is I'm just going to start pouring this in now real slow. Remember, I've got no heat going in here. See what that's going to do. Just want it to react by itself until it calms down so that we don't experience a boil over. It looks pretty docile. So what I'm going to do is I'm leaving the heat off. I'm going to put this on time lapse. I'm going to add the rest of our nitric acid. Now let's stop right there. That's about, still got about 20 milliliters of the nitric left. And let that reaction calm down. And then we're going to add the rest of that nitric. I'm going to put it on time lapse and do all that right now. It looks like all the gold dissolved early in the reaction. So now I'm concerned that there may be some excess nitric in there. So I crank up the heat to try to get it to evaporate down to drive off the excess nitric. And I take the lid off. And when I do that, it quits bubbling and it just evaporates quickly. I wasn't sure if I had all the excess nitric out of here. If you look, I can still see some fumes being formed in there. But I thought I seen some solids down in the bottom of the beaker. Let me give this a swirl. I don't know what that is in there. Yeah, I think I've got excess nitric in here. And I'm going to have to go ahead and evaporate this down before we can proceed. Evaporation is by far the best way to rid a gold solution of excess nitric. I've tried sulfamic acid and I didn't really like doing that. But there is another method that I've never tried, and we may have to give that a shot. Okay, it's getting late. And I've got a alternate method here to rid this solution of excess nitric. I've got a pure gold bar here, weighs 26.3 grams. And what we'll do is we're going to use this to consume any excess nitric that might be in our solution. So let's go ahead. I'm just going to drop this right on in. We're going to cover this up, bring it to a boil, and see if we get any fume production in here from that pure gold bar being down in the bottom of that beaker. You can see there's a little bit of a reaction when I first put it in there, a little bit of fumes being produced, but then it quickly subsides. All the fumes have cleared up. Our little gold bar's down here boiling, and I think we've got all the excess nitric out of this solution now. We're going to turn this heat off and let this cool down. Before I forget, let's put a little bit of sulfuric acid in this beaker to precipitate out any lead that may be present. I did get some precipitate formed down there. I don't know if you've seen that. Back here, this is the gold that we poured off earlier. It looks like I may have some metallic gold that was suspended and settled out on the bottom. Yeah, it's definitely some metallic gold in there. I can see it down in the bottom. We'll put this up on the heat. I'm going to add a little bit of hydrochloric acid to this. Just a little bit. Whoa. Now what I'll do is add a few milliliters of nitric acid. Try to get this gold that's come out of solution to go back in solution. It's about 3 milliliters of nitric acid. I think what's happening here is the gold solutions are so concentrated that it's looking for any reason to come out of solution. So I added a little bit more aqua regia and some heat and got all that to dissolve. I think we've got everything to go into solution here. I'm going to turn the heat off and let it cool down. I'm going to add a squirt of sulfuric acid, a little bit at a time. See if we get a precipitate to form in here. I don't see anything like that. I've allowed this solution to cool completely. We've got it to go in solution. I still got a little bit of solids left down there. We'll take a look at that in a minute. But for right now, we need to take a look at this one. This one is the one with the piece of gold in it. That's going to be like silver chloride, I think. I don't think that's going to be any gold. So I think we're just going to have to filter that out of this solution. Let's go ahead and ice these solutions down now. This ice is made from tap water with contaminants measured in parts per million. That's not enough to report in a precious metals assay. Got everything pulled through the filter now. So what we'll do is get our solids out of the beaker and down into the filter. I don't think that's gold. I don't know what that is. It might be lead, or it might be silver chloride. Not sure. There's our little gold bar up there. We'll get that out of there and weigh it up and see how much of that got dissolved during this process. That's how that looks. Gotta watch it here. We're running out of room down in our flask, and if you look here, this is condensate that's forming on the outside of the flask. I think our solution in there is very clear, and so I think we're going to be able to go with that. That's just condensation on there. Let's reach back here and get our other container. It's got a little bit of stuff in it, not sure what that is. I don't think it's gold. I think it's probably either silver chloride or the lead that we precipitated out when we added the sulfuric acid. Quickly running out of room, but I think we're going to have just enough to get all our gold solution down into this flask. Here we go. We're going to add the gold solution to this beaker full of ice. Using stump out to precipitate out the pure gold. Stump out by bonide. The other stuff is not sodium metabisulfite. But stump out by bonide is sodium metabisulfite. Here we go. We're going to precipitate out the pure gold. Here we go. And I just realized, as usual, forgot to test it with some stannous chloride, so we're going to get a little bit on this piece of filter paper right here. Verify that we've got some gold in solution. I mean, I know we do, but it's a good practice to verify with stannous chloride tests before we do the precipitation. I'm going to get in here and give it a stir. tell by the yellow color that we still got plenty of gold in solution. So let's just keep adding more SMB until we get all the gold to come out of the solution. Here we go. Just gonna dump it in, man. Stir this up. For a while I was wondering, kind of worried about whether or not we're going to have 15 troy ounces in here. But now that we're doing this precipitation, it's looking rather promising. This is our gold down here in the bottom of the beaker. This beaker is rather warm. Whenever precipitating this amount of gold, I always get a lot of heat from it. And that inhibits the precipitation and causes that gold to want to come back out of solution, especially if there's any amount of nitric acid in there at all. Let's do another stannous test and see where we're at with this. I'm thinking there's still plenty of gold in solution. And there is. See that dark stain? That means we still got a ton of gold needs to be precipitated out of the solution. Still pretty hot, so I'm going to put in a big chunk of ice. See if we get this thing cooled down. All right, let's keep adding SMB here. See if we can get the rest of this gold to come out of this solution. All right, I used a whole pound already. Opened up a fresh can. And now we're gonna try to get the rest of this gold to come out of this solution. See if we can make it happen. I'm just gonna pour this in now. Tell by the color, I think we've got it. All right, it's already starting to settle out. Just gonna put this lid on here and let it settle completely. Here's our little gold bar that we used to consume excess nitric in our solution. It started out as 26.3 grams. Let's see what we got left in here now. See how much we used up off of this little bar. 25.5 grams. So that means we used 0.8 grams, went into solution in that gold solution to consume the excess nitric. Let's test this to make sure we don't have any precious metals in solution. Don't think we do. It's got a little color in there, but it might just be some iron or traces of platinum group metals in there. I don't see anything on that stannous test. So what we'll do is just go ahead and pour this off now straight into one of my stock pots. If there is any precious metals in this solution that I'm pouring off, it'll be traces only and not worth trying to go after it to recover it. I'm putting it in my stock pot, which has copper in it. Any traces of precious metals in this liquid that I'm pouring off will cement out on the copper in the stock pot and accumulate in the stock pot, and then later on we can recover the precious metals from the stock pot. No reason we can't have a little fun with this. Stock pot is an essential tool for any refiner at any level. It's the first step in the waste treatment process. This is my temporary waste container, and it's full, so we're going to pour this off into the stock pot as well. Make some room in here. Get rid of this. Here's our gold. Looks pretty healthy. What we'll do now is rinse it over and over with some hot water. Rinsing the gold is a boring step, yet it is a vital and critical step because we get all the chemicals rinsed off with this hot water. And if there's any silver chloride in there with our gold, silver chloride is slightly soluble in water, more so in hot water, and we can dissolve that silver chloride in the hot water and then get it rinsed off of our gold. Going to boil the gold in some hydrochloric acid. Here we go. Boiling the gold in hydrochloric acid is another beneficial step. It will dissolve any traces of silver chloride that remain in the gold. Plus, it will dissolve and remove dissolved metals from the gold better than just plain water will. Toward the end of the boiling process, I reached in there with a glass rod and stirred it. I've allowed this to boil in hydrochloric acid for a little while. And what we're going to do now is go ahead and pour that hydrochloric acid boil off into our waste container. And I'm going to bring some water in here, some boiling water, and we're going to rinse the gold over and over with some boiling water. I never used to rinse the gold too much in boiling water like I'm doing here. I've just recently started doing this, maybe within the last year, and I've found that these hot water rinses really help clean the gold up nice for us, so that when we go to melt the gold, we get a nice, clear, clean, reflective bar of pure gold. I attribute that
to these repeated rinses with boiling water.
Got the weight written on the side of this dish. What we're going to do now is transfer our pure gold powder down into this dish so we can dry it out. Get it in here without making a mess. Gold. Let's see if we can knock it down a little bit. Get it flattened out just a touch before we put it in the water bath here to get it dried off. Alright, that should be good enough. Here we go. I'm going to stick this in this water bath. And then once we get most of that water evaporated off out of there, I'll take the water bath away and we'll go straight on the heat.
I always get a kick out of this. I don't know why, but I like to see that moisture being evaporated off of that pure gold.
I think we've got this all dried off now. Let's turn off the heat. Let this cool down. Oh yeah, nice pure gold powder, very nice. Here's our gold, and if you look down here, we were expecting 473.3, and I've got the weight written on here, 701.0, so let's see how close we got. That's 1173.5. 1173.5. 1173.5 minus 701 equals. Holy cow, look at that, man. Look at that. 472.5. And we're expecting 473.3. That's a relief, because when we were doing the refining out there, I was looking at the volume in some of those containers, and I was thinking, oh goodness, this doesn't look like that much gold. But thankfully, it came out almost perfect. Mrs. Three Tips has directed me to put the gold in something with a tight fitting lid. So let's go ahead and get this set up and do that right now. And we're gonna just go ahead and empty the gold into this container with a tight fitting lid, which makes sense. I mean, so we can do this without making a mess. 472.7 grams. Let's put the lid on this thing so we can keep it safe. It's got a locking lid on it. All right, we got 472.7 grams. Divide that by 31.1 grams. We get 15.19 troy ounces. And I think gold's at like 3,600 right now. So it looks like we've got $54,717 worth of high purity gold in this container. I wanted to get a shot of my electrolytic silver cell into the video here. That's the voltage, 3.5 volts, and the current flow through the cell is about 1.1 amps right now. And I was having a problem with this thing in that the crystal growth down here underneath the anode filter basket was growing rapidly right down there underneath the filter basket, forming these tiny needle-like crystals that wanted to grow up and make contact with the anode filter basket. And if that happens, it'll burn a hole in the anode filter up here and short the cell out, and then the silver cell slimes will leach down into the silver cell and ruin the batch of silver. But as you can see, it's working perfect now. I mean, it's working just like my small 3.5 liter cell. This is a 6 liter cell. And I've got all that sorted out now, dialed in pretty good. All I did was put a spacer to raise the anode filter basket up just a few millimeters, and it was enough to create more resistance and slow that growth down below the anode filter basket. And this is my electrolytic silver cell. I mean, they just passed a big, beautiful bill, and they're going to pay for it with a big, beautiful printing press. And I've got a big, beautiful silver cell to counteract the action of the destruction of the currency that's going to occur when they print all the money that they need to pay for their big, beautiful bill. And maybe when silver gets up over $100, I'll start making some pure silver bars and stamping them up and selling them on my eBay site. Here I'm preheating a large fused silicon melt dish to drive off any excess moisture that might be in there. Then I start adding tiny pinches of borax to glaze the inside of the melt dish with that borax. And what this will do for me is when we go to melt the gold, this will prevent the gold from sticking to the inside of the melt dish. This is what a properly glazed melt dish should look like. Look at that thing, man. Oh boy, Miss Sweet Tips told me to put a rag in there and I forgot to do it. That's too late now. Oh boy, look at that thing, man.
In the early 2000s, we used to buy a handful of gold for a few $100s. Then it turned to a few $1,000s for a handful of gold. Today, it's up to tens of thousands for a handful of gold. And the time is coming where it's going to take hundreds of thousands for a handful of gold.
Here's our freshly minted pure gold bar. I don't know if you can see it or not, but if you hit the light just right with this thing, it's got those little speckles in it, just like the high purity silver does. Man, this thing came out wonderful. It's absolutely beautiful. Very pleased with it. Let's see what we got for a weight on this thing. 471.6. Where's my calculator? 471.6. 471.6 divided by 31.1. 15.16 troy ounces of pure gold. Man, the thing's nice. Good Lord. I can see my reflection in it. I'm very pleased with it. All right, this will conclude the 15 troy ounce pure gold bar refining part 2. Thank you for watching.